We have seen how white light can be split into its different wavelengths, that is, different colours, using refraction. Now we're going to look more at these colours, these pigments that are part of the world. You'll need some alcohol. You can get it from pharmacy, or you can go back to your old vodka, some jars, glass jars, tissues, absorbent paper. You want some scissors. I've got a guide here. You can get these guides from the Marine Studies Centre at University of Otago, and we've got these seaweeds, and you'll find it's divided into different coloured groups: red seaweeds, brown seaweeds, and the green seaweeds. And these pigments that give them the colours and the general group names, brown on the left here, red in the middle, green, these are photopigments, that is, they are light sensitive pigments. These are the pigments that enable photosynthesis to occur. Here's some red coralline algae. It's a small encrusting red algae. If you don't have these seaweeds, you can get access to other pigment sources. Obviously any green leaf. I've got some broadleaf here, some flax, some pahutakawa. These are around the place, grass, whatever you've got.
So first of all, I'm going to cut some strips of my paper. The more absorbent the paper, the better. And I'm going to test different sorts, the sort of drawing sketch pad, but also this paper, which is a bit thicker and more absorbent, which is used for watercolour painting. And I just want a long, thin strip that I will cut to a length that fits in my jar. So with the jar, we're going to hang them down into the jar, so about half of that would be about right. And now I've got my strips of paper, and then on the bottom of that paper, using a ruler and a pencil, I will mark where I'm going to put my pigments.
So these pigments, the photopigments, the sensitive to light, carry out photosynthesis, I'm going to make sure they're absorbed into this paper, and you want to make your mark just maybe 1 centimetre, not too far up from the bottom. You don't want to be far from the liquid that we're going to use. Have a look there. And we're going to try and keep the pigment on that, or on or near that line, so it's pretty much the same for all of them. And to do that, you get something firm like the end of a pencil, and get your plant material. Here I've got the filamentous red seaweed, and give it a good bash and get that pigment out. You do this 3 or 4 times, let it dry a bit and then put a bit more on. Here I've got the broadleaf. Really have to give this quite a hard bash to get it out, and then let that dry, and then do it again, repeat it. So here we are. Here we've got our pigment on, red filamentous, and the broadleaf there. I'm going to do 2 sets of 3 different seaweeds, brown, red and green, and 3 different green terrestrial leaves. What I've done is I've pegged them to a cardboard form, and then I'm going to put a little bit of the alcohol in. You can use water, but alcohol is going to work a lot better. And then have it so that the tips of the papers are at the bottom of the jar, but the level of the water is below the pigment. You don't want that the alcohol touching the pigment. I've got a peg, the green peg on the side here I'm using just to hold that upright, and we're going to leave it for a wee while. It won't take very long, and what happens is the alcohol moves up the paper, and as it goes through the pigment, it picks the pigments up, and depending on the type of pigment, how well it attaches to the alcohol, and the size of the molecule will depend how fast and far it travels up the paper. This being the case, the different pigments, photopigments, will be separated out. This is chromatography, chromo meaning colour, and graph meaning a form, a shape, a presentation. So we can see a graph of shape of the different coloured pigments. Greens here, chlorophylls, the yellows and the orange carotenoids spread out, and separated out by this process. These molecules are synthesized with the energy of light and in turn absorb and transform the energy of light for forming the energy of life.